Welcome to AB Academy. How to calculate molarity using a very simple trick. Firstly, let me quickly revise the concept of molarity. We define molarity as the number of moles of solute dissolved in 1 liter solution. The formula of molarity is m equals n upon v, where m is the molarity of a solution, n is the number of moles of solute, v is the volume of a solution. For example, consider that I take 4 moles of nitric acid in this volumetric flask. Now I add water to this volumetric flask until the water level reached 1 liter mark. Here in this volumetric flask, the volume of a solution is 1 liter. We know that we have dissolved 4 moles of HNO3 in this 1 liter solution. So the molarity of this solution is 4m. Remember that 1 liter is equal to 1 dm cube. 1 dm cube is equal to 1000 centimeter cube or 1000 milliliter. Now how can we calculate molarity using easy trick? Let's see some numerical problems on molarity. Here in this question 0.7 moles of sulfuric acid is dissolved. So the number of moles of solute n equals 0.7 mole. Secondly, the volume of solution is 600 ml. Remember that the volume of a solution is given in milliliter or centimeter cube. We have to convert it into liter. Now to do so, the easy trick is to move the decimal point 3 times to the left or dividing milliliter by 1000. After moving the decimal point 3 times to the left, I get 0.6 liter. We already know that molarity m equals n upon v. Here n equals 0.7 mole and v is 0.6 liter. I plug in these two values in this equation. After calculation, I get 1.16 mole per liter or just 1.16 m. Thus, the molarity of this solution is 1.16 m. Now, in this question, 0.5 mole of nitric acid is dissolved. So, the number of moles of a solute is 0.5 mole. Secondly, the volume of a solution is 800 centimeter cube. I convert it to liter. To do so, I move the decimal point 3 times to the left. I get 0.8 liter. We already know that the formula of molarity. The value of n is 0.5 mole and the value of v is 0.8 liter. I plug in these two values in this equation. After calculation, I get 0.62 mole per liter or just 0.62 m. So the molarity of this solution is 0.62 m. Now let's see some hard level questions on molarity. Consider these numerical problems on molarity. Here in this question, instead of moles of a solute, mass of a solute is given, like 5 grams of sodium chloride. Remember that in such type of numericals, we have to convert the mass of a solute into the number of moles of a solute. Firstly, I find the molar mass of sodium chloride. I write sodium plus chlorine. The molar mass of sodium is 22.99 gram. The molar mass of chlorine is 35.45 gram. After addition, I get 58.44 gram. So the number of moles of sodium chloride is 58.44 gram. Now to find the number of moles of sodium chloride, I divide the given mass of sodium chloride by its molar mass. The given mass of sodium chloride is 5 gram and the molar mass of sodium chloride is 58.44 gram. After calculation, I get 0.085 mole. Hence, the number of moles of a solute n equals 0.085 mole. Secondly, the volume of a solution is 900 centimeter cube. I convert it to liter. I move the decimal point 3 times to the left. I get 0.9 liter. We know that molarity of a solution is m equals n upon v. The value of n is 0.085 mole and the value of v is 0.9 liter. I plug in these two values in this equation. After calculation, I get 0.094 mole per liter or 0.094 m. So the molarity of this solution is 0.094 m. Lastly, pause the video and try to solve the numerical problem. In this question, firstly I find the molar mass of hydrochloric acid. I write hydrogen plus chlorine. The molar mass of hydrogen is 1 gram and that of chlorine is 35.45 gram. After addition, I get 36.45 gram. Now find the number of moles of solute. I divide given mass of hydrochloric acid by its molar mass. The given mass is 16 gram and the molar mass is 36.45 gram. After calculation, I get 0.43 mole. Secondly, the volume of a solution is 0.6 dm cube. We already know that 1 liter is equal to 1 dm cube. So 0.6 dm cube is equal to 0.6 liter. Also we know that molarity is equal to n upon v. I plug in these two values in this equation. After calculation, I get 0.71 mole per liter or just 0.71 m. Thus the molarity of this solution is 0.71 m. Therefore, using this simple trick, we can easily calculate the molarity of any solution. Thanks for watching. Please like, share, comment and subscribe my channel.